Hello, and welcome back to the video for lesson 5.4. We are going to learn about trigonometric functions at any angle using right triangles. Okay, so we're going to learn about definitions. We're also going to find exact values of these trig functions of certain special angles. We're going to learn how to use reference angles and also implementing trigonometric functions through the Pythagorean theorem. So, if we have any point x, y, and theta is the angle and standard position, whose terminal side is the ray from the origin passing through that point, let the radius be equal to the square root of x squared plus y squared. And if that's true, then we know these values for cosine, sine, tangent, cotangent, secant, and cosecant. Okay, so it's essentially what we've been looking at. It is the opposite over the adjacent for tangent. It is the opposite over the hypotenuse still, because R is our hypotenuse, basically. And in this case, Y is the opposite value, and X is the adjacent. Okay, so let's look at example 1. It says, let X, Y be the point 4, -3. So 4 would be a +4, and then down a -3. That would be the point here. And then we're going to draw the angle that comes out from there. And so there's my angle theta. Find the exact value of all trig functions of theta. Okay, so we know our adjacent and our opposite. So we went over 4 and down 3. So we already we're looking for sine of theta, cosine of theta, tangent of theta. We know tangent of theta because it is the opposite over the adjacent. So that's a -3 over 4. And so we know the cotangent of theta is a -4 over 3 because that's the reciprocal. And we know that cosecant is going to be the reciprocal of sine, and secant is the reciprocal of cosine. Okay, so we have to find the hypotenuse. So we know that 4 squared plus a -3 squared equals the hypotenuse, or r squared, right? Our radius that comes out, r. And so 16 plus 9 equals r squared, and that is 25. And so if we take the square root of both sides, we know that r is 5. So this is a nice smooth one with all integer values. By the way, remember that 3, 4, 5 is one of those perfect triangles that the numbers go in a row for A, B, and C. So we now know that our opposite is a -3 over hypotenuse. So there's our sine. And so we know that the reciprocal, or cosecant, is going to be a -5/3. And then cosine is the adjacent over the hypotenuse. So that's 4/5 positive. And secant is the reciprocal of that, or 5/4. So let's see if we can implement what we know about where the values of the trig functions are positive and negative. So suppose that cosine of theta is greater than 0. We know that cosine is x, and cosine is positive anywhere in the first quadrant and the second quadrant. So this is happening in the first and the second. I'm sorry, the first and the fourth. I pointed to the fourth and I said the second. And then we also know that cosecant is positive in cosecant is the reciprocal of sine. So cosecant is positive wherever sine is positive. Sine is positive in the first and the second. So is cosecant. So in what quadrant must its terminal side lie? It has to be in where they are similar. So this must be in the first quadrant. Okay. Quadrantial angles. When the terminal side of an angle lies on the horizontal or vertical axes, it is referred to as a quadrantial angle. The values of this trigonometric functions for these angles can still be calculated from the given definition, but some values may be undefined. So it says find the exact values of sine and cosine when theta is 270. So when the angle is 270, that is all the way here. This is 270 degrees. And so that means that we are at the point of 0 and a -1, which is cosine and sine. So we know that we know that sine at 270 is equal to a -1. And then we know that cosine at 270 is equal to 0. And that's also in the table down below. Example 4. We're going to use references. So for an angle theta in standard position, whose terminal side lies in one of the 4 quadrants, the reference angle for theta is the acute angle that the terminal side of theta makes with the x-axis. So if this right here is our angle in the second quadrant, then the reference angle is this little one here. If it's in the third quadrant, then our reference angle goes up to the x-axis, and that is our reference angle. So here's our reference angle, here's our reference angle. And if it goes all the way around to the fourth quadrant, then it goes up to the x-axis again, and this is our reference angle. So example 4 says, find the reference angle for 330 degrees. So 330 means we're going all the way past 180. We're going to go all the way past 270, and it's going to be in this fourth quadrant. So in the fourth quadrant. And so 360 minus 330 is going to be our reference angle here of 30 degrees. Is our reference angle. Okay, let's look at example 5. It says, find the sine of a negative 4 pi over 3 and the cosine of a negative 4 pi over 3. Okay, so a negative 4 pi over 3 means that I'm 1 1/3, because 4/3 is 1 1/3. So that really means at a negative pi over 3 is what we're looking at, because we're going to go all the way around once and then again a third of the way. So pi over 3 is the same as a negative 60 degrees. And so a negative 60 degrees is also the same as a positive 300 degrees. And so that's the same as saying sine at 300 is the same as saying sine at 5 pi over 3. And that is a negative square root of 3 over 2. And now some of these we just know because we've got the use of our circle that we've been working with. So sine is a negative square root of 3/2 at 300, and cosine is 1/2. Section C, it says trigonometric functions of coterminal angles. So coterminal means that they are either greater than 360, so you're going to add 360 or you're going to subtract 360. So find the exact value of cosine of 495. So we're first going to subtract 360. So it has to be within 0 and 360 degrees. So this is cosine at 135. So let's look and see if that's 1 on our unit circle, and 135 is on our unit circle. So cosine at 135 is negative in the second quadrant. It's a negative square root of 2/2. Now we're looking at relating trig functions. And so it says, example 7 reads, suppose sine of theta is a negative 2/3 and the terminal side of theta lies in the third quadrant. Find cosine theta and tangent theta. Okay, so we're first going to draw what this looks like. So we know it's in the third quadrant and sine is negative in the third quadrant. So that means that we're going to draw this picture here. And sine is a negative 2/3, which is the opposite over the hypotenuse. So that means my hypotenuse is 3 and sine is the opposite is -2. So I know this information. So I don't know what cosine is. I don't know. I mean, I don't know what this x value is. I know it's negative, but I don't know what it is. So I know that x squared plus a -2 squared equals 3 squared, because I know a side and my hypotenuse. So x squared plus 4 equals 9. So x squared equals 5 when I subtract 4. And taking the square root of both sides, I get x is the square root of 5. But because I know that it is in the third quadrant, I know that it's actually the negative square root of 5, because because x is negative in the third quadrant. Okay, so if that is true, then I know that cosine of theta is going to be the adjacent, which is that negative square root of 5 over the hypotenuse, which is 3. And then I know that tangent of theta is sine over cosine, or the opposite, a -2 over the adjacent, which is a negative square root of 5. But I have to rationalize that. My negatives cancel. And to rationalize, I have to multiply by the square root of 5 over 5. And so I end up with 2 times the square root of 5 over the square root of 25. And that simplifies to 2 times the square root of 5 over 5, which is what we wanted. We wanted a rational number there in the denominator. So getting really good at drawing these points and knowing what quadrant you're in, and then using the Pythagorean theorem to find the third side. And the last example for this lesson is all about using the scientific calculator. So it says use a calculator to find the cosine of 197 and secant of 197. And I'm going to share my screen to do that. And here we are. So I'm going to take the cosine of, and I have to turn this into degrees. So there, I'm in degrees. So 197. And that is a negative 0.9563. And then secant. So secant is 1 over cosine. So that's going to be 1 divided by a negative 0.9563. So that is a negative 1.046. And that is the end for lesson 4.5. Catch me back for another lesson. Let me show you what this looks like on my paper, just in case you were wondering. Right here. And like I said, catch me back for lesson 4.6.